Hello. Hello. Yeah. Good evening, everyone. Uh, can you please verify that I am audible to you?
Yes, sir.
Okay. Just inform me once when the screen will be visible.
No, sir, it's not visible.
Yeah. Kindly check it now.
Yes, sir.
Is it visible?
Yes, sir.
Yes, sir.
Yeah. Great. And okay. Are you able to see the slideshow?
Yes, sir.
Okay, great. So hello, myself Shubham Krishna Gorge. I am a senior EV trainer at ISI India, and today we are going to see the global landscape of advanced EV charging technologies all over the world as well as in India. So today is 20 April and we are conducting this webinar on advanced technologies in EV charging across the global landscape on 20 April 2024 at 5 p.m. So as we all know, electric vehicle is future of the world, and as we are moving towards the 2030, the electric vehicles are coming into the market, right? So the Indian target is to be like 50% dependent on e-mobility by the 2030 and 100% by the 2050. Yeah. Hello. Yeah. I think someone's mic is on. Can you please turn off it? Okay. So as we all know that the EV is the future of the world, EV is the future of the mobility, and as moving, so like petrol pumps, right? Like petrol pumps, we need to refuel our normal internal combustion engine vehicle with the help of petrol, diesel. So we are having petrol pumps. So similar wise to refuel the EV, every battery made in this world is DC, right? So whenever we need to charge that battery, we'll need to give that battery DC supply only. So there is two types of charging station, AC charging station and DC charging system. So we need to convert AC to DC from the onboard converter. So there are two conditions here. We are converting AC to DC inside the vehicle, and in DC charging system, we are converting that AC to DC outside the vehicle. Just note the difference, right? Just try to understand the difference. In case one, in AC charging system, we are providing AC supply to the vehicle battery pack, which runs on the 350 to 500 volt. Just can you imagine the how high volt this is? We are getting 220 to 230 to 40 volts in our household supplies, and this is like way double 2x from that our household supply, domestic supply, right? So just while we are charging or while we are doing the maintenance of any kind of electric vehicle, we need to be very safe. We need to follow the safety compliances. We need to be very careful when we are handling the electric vehicles, and even when we are traveling in the electric vehicle, right? So see, here are different levels, right? So as I have told you, there are two types of chargings. First was AC and DC. That is nothing but onboard and offboard. So again, there is different types of levels of charging. So there are basically three levels of charging: level 1, level 2, and level 3. So level 1 is nothing but basic home charging, means whatever supply we are getting at home, like we are normally we are connecting our microwave or a fridge or any kind of high voltage supply, right? Like geysers or AC. So at that power points, we can directly connect that charger, and we can charge our vehicle, right? So this is basic level 1 charge. What happens in level 2? In level 2 is EVSC home charging. Here we are having special unit which is known as EVSC, and at that that EVSC is powered by the different wire from the domestic supply, right? Have you seen from where we are getting the electrical supply? From that pole, right? At our house, that meter is connected to the wire which we are getting from that pole. Have you seen that? Hello. Okay. Am I audible to you all?
Yes,
Yes,
sir.
sir.
Yes, sir.
So we are powering this EVSA from different wiring connections which we are getting from the domestic supply, right? And DC fast charging station are specially made to charge our vehicle at fast speed at the higher current and a higher voltage level within the minutes. And this DC fast charging stations are exclusive available only at their power points or only at some places like malls or some charging stations, just like petrol pumps and all that, right? So there are different types of voltage levels. As we can see, at level 1 we are having 120 volt. At level 2 we are having 240 volt, and at level 3 we are having 480 volt. So just you can see that how much uh, like time difference it can make by charging the vehicles, right? So it will add 5 miles per hour of charge, right? As we can see here, you can see here, right? Like for how much time if we'll charge it. See, you can see it will add 60 to 100 miles for 20-minute charge, right? It is for commercial use, and level 2 is for residential as well as commercial use. It will add to 20 to 60 miles per hour of charge, and this 120 volt will just add 5 miles per hour of charge. Means when I'll charge my electric vehicle for 1 hour at level 1, I can just travel up to 5 miles. If I'll charge my electric vehicle for an hour at the level 2, I can travel 20 to 60 miles. And at level 3, which is 480 volt DC fast charger, if I'll charge my electric vehicle just for 20 minutes, it will give me the range of 60 to 100 miles. So see, you can notice the difference. There is very significant difference here because we are charging it at double the voltage of level 2, right? So this is the level 1. Level 1 charging refers to the basic method of charging electric vehicles using the standard power outlet or standard household electrical outlet, and it will give us just up to 3.5 kilowatt. This level of charging is the slowest, as I have told you. It will give us very low range if I'll charge it for hours, and it is more suitable for the overnight charging. Means as soon as I get from the office or from the college, I need to go and plug in my vehicle, and I will get this significant range at tomorrow morning. Means overnight, I need to charge that electric vehicle. To facilitate level 1 charging, EV owners use that standard charging cables that comes with them. Means we are getting a normal charging cables which I can directly plug in into my household electrical outlet, and I can charge my vehicle. But what happens in level 2? In level 2, it is more advanced and faster charging methods as compared to level 1. It output ranges from 3 kilowatt to 22 kilowatt. EV owner choose to install level 2 home charging station to accelerate the charging process compared to standard household outlets, right? And what happens in level 3? Level 3 is also known as DC fast charging. It is the fastest and most powerful method for charging the electric vehicle available for the public use, with the output range of 22 kilowatt up to the 40 kilowatt. 400 kilowatt. Means you can see the significant increase in this kilowatts. First we are having just 3.3, then we were charging up to like the 3 to 10, and now we can see 22 to 400 kilowatt. We can get the output ranges from this level 3 charging. Unlike like level 1 and level 2, level 3 charging uses direct current, right? And it provides us the rapid charging option, and it is suitable for the long distance as well as quick charging. Just like our mobile phones, we are having fast charging methods, right? Like some of the mobile phones, if we will charge, it will get charged up to 80% within the 5 minutes, within to 10 minutes. Similar way, when we are using level 3 charging, it will get charged within the 20 minutes, 30 minutes, up to the 80% or 60%, right? So see, level 1, it is the outlet is of 120 volt, and we are having the regular household circuit, and the range is of 2.5 miles for the 1 hour of charging. Again for level 2, 20 volt, right? We can see this, the charge time is 1 hour, and we will get 10 to 20 miles of range. And at DC fast charging, we are having 3-phase AC supply, right? So here we are providing 3-phase AC supply to the electrical power station, and that 3-phase AC supply will be converted into the pure DC, and that DC will be given directly to our electric vehicle. See, what happens in first 2 cases, the AC is converted into DC with the help of onboard charger, and DC fast charger is the offboard charger. Means where at the outset we will convert AC to DC and directly provided to the electric vehicle. Yes, any questions?
Hello, so hello, Mr. Subham.
Yes, sir.
Am I audible?
Yes, you are.
I just want to ask you one thing. As we know that about the battery swapping policy, which is not actually exactly proper in India. Like say, there's a lot of issues like Exide batteries could not be properly that Exide properly replaced with the MRO and all. So, wow, is battery swapping policies?
Sorry, sir, you are not properly audible.
Hello, am I audible, Mr. Subham?
Yes, you are not audible.
I am asking that what would you like to say about the battery swapping policies in India? Because nowadays, as we know that this Exide, MRON, like most of the batteries, sometimes they don't have that exact dimension, same dimensional criteria. They are not following that. So when let's say some vehicle is using at the time of when they are buying that, they might have Exide, but when they are going to replace, the MRON could not be properly fitted with them. So what do you like to say about that?
Right, sir. So see, now till now our the charging units or the infrastructure for the charging or swapping the batteries has not been developed yet in the India, right? So as we are moving forward, as we look past some few years, I think so, I hope so, that it will get standardized. See, the Excite or Ambron you're talking about, that all are making that are into lead acid battery. But in electric vehicles, we are not using lead acid battery, we are using lithium ion battery.
Just
right.
As an example, I'm saying, just an example I'm saying. That a lot of this standardization is
Yeah,
not yet maintained.
yeah,
Standardization is not yet
but
maintained.
I like to add on into this. See, the major players in the electric market nowadays is like Tata, or in case of two-wheeler is TVS, Ola, right, and Bajaj. So if I talk about Ola, so it may happen in the future that Ola will make this special swapping station just for the Ola bikes, right? So even if the vehicle is changing, the Ola model will remain same. So batteries will remain same in that, the dimensions will remain same in that. And it may happen that the government policies of India will become such that battery in all kind of electric two-wheelers should be same, the dimensions should be same. Nowadays, like how we are having the standards for the internal combustion engine vehicle. Just take an example. Let's take any kind of internal combustion engine scooter. We are using it petrol only, right? We are providing petrol into the bikes. There is no bike which runs on the diesel. So it's standard. Like it has took lots of years, like it took 50 years to get the proper petrol and the diesel infrastructure in the India. So there might be some good infrastructure in the future waiting for us. There might be some good government policies which will like segregate all these things, which will combine all these things, and they will make some standard units so that the voltage, current, again the charging units will remain same. You can also take the example of mobile phone, right? All the Android phones are having C type, right? Before that there was USB, before that there was a 2.2 pin charger. So now everything is getting standardized. So on the electric vehicle will also get standardized regardless of charging, again the swapping stations, wireless charging stations, right?
Okay, thank you.
I hope you got my point.
Yeah, okay. Thank you. Thank you, sir. Thank you.
Okay. So shall I continue? So electric vehicle supply equipment, EVSE. EVSE is the basic unit of EV charging infrastructure, and EVSE control system enables the various functions such as user authentication, authorization for charging, information recording, exchange of network management, and data privacy and security. So what is EVSE? So see, just like our ATMs, right? So what does an ATMs do? As we put the ATM card inside the ATM, we enter some OTPs, or we enter some passcodes, and we enter the amount and we get the cash, right? Same like that. What is the electric vehicle supply equipment? Whenever I need to charge my electric vehicle, I plug in my electric vehicle into that supply equipment. After that, I'll be having one card, or I will be having some codes that I will enter into that, or I will swipe my card on that supply equipment. Then and then only the electric vehicle will get charged. Right? Are you getting my point? Just like our petrol pumps. What we are doing there, we need to refuel our tanks. So what we do, we give cash and we refuel. So how we will charge our electric vehicles? So to charge our electric vehicles, we are having this electric vehicle supply equipment. This is used for user authentication, authorization for charging, right? It will again record the data, how much time you have charged your vehicle, how much kilometer it can travel. It will exchange the data from the networks, from the other stations. Again, there will be some securities. So this is the use of EVSE, right? So there are some main components of EVSE like power supply unit, which will provide the power to the electric vehicle, connectors and cables, controls and communications module to control with the to communicate with the Wi-Fi, to communicate with the clouds, to communicate with the user, right? To communicate with the owner. Ground fault protection if there is any kind of fault, any kind of short circuit inside that. Metering system is there. to see that how much electric charge has been consumed by the electric vehicle. Again, the user interface, so that we can easily use that electric supply equipment. Authentication and payment system. What is authentication and payment system? Like biometrics or passcodes or any kind of OTPs, right? And payment system, like it's like cash, or it's online, or it's on credit system, right? So these are different types of components there are which is present inside the EVSE. So now we are going to see charging stations. So see, you can see there is onboard charger and BMS plus battery inside the electric vehicle. So what does the onboard charger do? You can see here, as I am connecting my AC charger to the electric vehicle, right? What will the onboard charger do? Onboard charger will convert the alternating current into direct current, and it will give to the battery. What is BMS? BMS is nothing but the battery management system, right? Which will keep the eye on the charging, all the charging factors, temperatures, and all these things. So this is fixed charging station, right? So I need to park my vehicle. I need to plug in my vehicle with the help of that cables to the AC charger, and my vehicle will remain at one place till it gets charged. All right, so this is fixed charging station. Another type of fixed charging station is DC charging station. What does the DC charging station do? It will convert AC into DC at this external unit only, right? And with the help of these connectors, I'll connect to the vehicle, and the DC supply will be directly given to the vehicle, and my battery will get charged, right? So this supply is directly given to the BMS and battery. Why? Because I am already converting the supply from AC to DC from the external unit.
Shubham sir.
Hello.
Hello, Shubham sir.
Yes, am I audible?
Yes. I have a question regarding
Yes.
DC charging stations, as you spoke just now. So I read in some of the article where it has been mentioned that if we charge our vehicle from DC charging system, so battery life will be affected from
Yes.
that. Is it true?
Yeah. Yes, sir. Kind of it's true. But see, what does the DC charger do? It fast charge our electric vehicle, right?
Yes, sir. Yes.
So if my vehicle is charging at faster speed, means it is going from 50 to 80, like, or 0 to 80 within the 20 minutes, what will it do? It will increase the temperature of the battery, right? Because I'm forcing the charge to move fastly, to move vigorously, so that my battery will get fastly charged up to the 80%. And when it is getting charged at this so much higher speed, eventually it will heat. That's obvious, right? So it will damage the life of the battery. It will damage some internal components of the battery. But there is a remedy for it. So see, the DC charging is suggested only in case of emergencies.
Okay, fine.
Right.
Fine.
So
No,
if you are traveling from highways, right, when you really need that charge, or like if you are traveling from one place to another, like 100 or 1,000 kilometers, you can charging so that you can just reach destination. And when you will reach up to your destination, again you can charge your vehicle at the lower speeds.
Yes. Fine. Thank you.
But there is only there is also the like most advanced technologies coming into the market nowadays. There will be some more advancement in technology in the future, which will eliminate this disadvantage from the EVs. Right. So moving forward, the EV charging system modes, there are two modes where we are charging the EV in AC supply and DC supply. So mode 1, mode 2 and mode 3 is in the AC and mode 4 will be DC, right? So when we are charging from 22 kilowatt to 22 kilowatt and in DC, it will be 2 kilowatt to 200 kilowatt. So here you can see the clear difference. Whenever we are charging with AC, we need to give this AC supply first to the onboard charging. What this onboard charging is doing? It is converting AC to DC and then giving it to the battery. And in mode 4, which is DC, what it is doing? It is converting AC into DC from external source, and it is directly providing DC to the battery. So next is wireless static charging station. First of all, we have seen the fixed charging station. Now this is wireless static charging station. So just like our mobile phones, how we are charging mobile phones wirelessly, we are having two coils, right? One is the transferer, is the receiver. Hello. Hello. Hello, am I audible?
Okay.
Yes, yes, sir, you are audible.
Hello. Hello.
You are audible.
Yes,
Yeah,
you are
I'm
audible.
Yeah, there was some network issue. Yeah, wireless static charging stations, right? So what is wireless static charging stations? So here we are charging our electric vehicle with the help of the wireless methods, right? Here we are charging our electric vehicles with the help of wireless methods, just like our mobile phones. So there is two coils. So there are two coils. One is sender and one is receiver, just like our mobile phones. So we are transferring that electrical charge or with the means of the induction, right? Here, all the things is going with the help of induction. Like, how can I tell you that? The electromagnetic field, right? The electromagnetic field is getting indulged in within them, and they are transferring the power just like this. See, this is the charged coil, and this is connected to the battery pack, right? Here we are getting the electromagnetic field, which is inducing the EMF in this coil, and the battery is getting charged. So like this kind of wireless charging stations will be placed on the parking areas where you will just go and park your vehicle and it will get automatically charged. Here you will not need to go and to connect any kind of charger or connect any kind of cable. Here you just need to park your vehicle and it will get charged. Another is dynamic charging. There will be some lanes or there will be some roads where the wireless charging will be fitted inside that, installed inside that, and whenever your vehicle will travel, it will get charged, right? So first one was the fixed and this is the dynamic. Whenever your vehicle will be moving, it will get charged. Battery swapping station, C. What is battery swapping station? Here we need to just put on your discharge battery and get the charge tone, right? So this is not majorly used inside the India till now, but it's used in abroad in many countries. It's used nowadays. See, here you are having the charged battery packs. You will need to recharge them. You will need to put them. You will need to pay for them, and you will remove and you will take the charged one, right? So this is the future of the battery charging. See, there are different types of charging connectors. That is AC charging connectors. It is mostly used in USA. There are 5 number of pins here, and the typical power rating is 3.3 kilowatt to 7 kilowatt. Combined charging system, CSS, right? So this CSS charging station was created in Europe, and it's currently the mostly wide used standard global. It is having 5 pins, and it can charge the vehicle up to the power rating of 350 kilowatt, right? It is again having the DC supply, DC supply and other functions. And the next one is CHAdeMO, CHADEMO. It was created in Japan. It is having 10 number of pins. Again, it is having CAN communication, which will communicate with our vehicle, and its power rating is up to 400 kilowatts. And again, the next one is the solar power charging station or solar based charging station. Here we are having solar grid, which is connected to the DC fast charging station. The power from that solar grid will be converted, will be given to the DC fast charging. It will again be manipulated. It will be escalated. The step up will be done of the voltage and current, and it will be provided to the vehicle directly. Again, whenever we are not having DC fast charging, we can charge our vehicle with the normal onboard charger tools. So if we are charging our electric vehicle with the help of solar energy, it will be totally green energy. That's all from my side. The audience is open for the question. If there are any questions, you can ask.
Facebook, Instagram, WhatsApp, Facebook, Instagram, YouTube, and WhatsApp, Facebook, Instagram, and YouTube, WhatsApp.
Hello. Are you able to hear me? Hello.
Hello, yes, sir, you're audible.
Whether this wireless dynamic and it is in use and where it is being used, because in the India the charging stations are now a big problem. So, you said
Yes.
no.
Yes,
The
yes.
wireless charging as well as dynamic charging you just mentioned. No?
Yes,
Or
sir.
it is
The wireless charging methods are still into the research process.
Okay.
Or it's still
Yeah,
developing.
this is the kind of future plan. So it should be.
Yeah. It's just it's just been modularized now. It's just been simulated now. It has been implemented solely for the normal users. They are just trying to make it more better for the future.
Okay. Because the induction charging, it's very good. I think. Thank you. Besides Professor Bharat Singh.
Thank you. Yes, any other questions, please?
It was good narration and session, I should say. Thank you.
Thank you so much.
డేటా లేదు అందులో డేటా లేదు ఏం చెప్తాను ఏం కావాలి చెప్పలేదు దేనికి
Yes, your question, please.
నోటిఫికేషన్ చూసుకున్నావా? ఏం చూస్తాం?
Thank you so much for the wonderful session, sir.
Hello,
Yes.
what about certificate, sir?
Yeah, that will be provided by our team. Don't worry. Yeah, any other questions, please?
No, sir.
Sir, can you say what type of battery is most suitable for the EV, sir, in the upcoming?
Yeah, nowadays we are solely dependent on the lithium-ion batteries. Still, we are trying to make them better. That the future will be future may be like hydrogen cells, or again the salt batteries is there, right? So there are more developments going on inside the batteries department, but still now we are totally dependent on the lithium-ion cells.
Okay, sir. Thank you.
Yeah. Any other questions, please?
Hello, sir.
Yes.
What's the hybrid electric vehicle, sir?
Hybrid electric vehicle is the vehicle which runs on fuel as well as battery. It is having motor and also it is having the internal combustion engine. Whenever the electric vehicle will run on that battery, the fuel or that internal combustion engine will remain off, and whenever it will remain off, whenever the motor will remain off, the vehicle will run on motor. Again, there are different types. There are series, parallel, which we will be covering in the upcoming webinars. You can join them and you can learn all these things. Again, you can learn about the parallel vehicles, hybrid electric vehicles. Again, from the basics to the advanced on our sites we are having some courses on that. You can see them, you can learn, and you can get more advanced into the electric vehicles. You can visit our website, that is imperialsociety.in, for more information.
So what are the highest capacity of batteries?
See, it depends. We are using on electric vehicle, we are using it for the 2-wheelers or 4-wheelers. There are different capacities like 80 kilowatt hour or 100 kilowatt hour, 200 kilowatt hour. It depends on the manufacturer. It depends on the user.
Hello, sir. I have a question.
Yes, please.
Sir, I wanted to ask about what is the status of the electrified recharging road? How successful that is going to be? Like, would you like to comment something on this?
You're talking about dynamic wireless charging?
Exactly. Dynamic wireless charging. Yes, that has recently opened up in Sweden also.
Yeah. So see, nowadays, even if you will be charging that electric vehicle with the help of that wireless charging, we will need to cover up like lots of area. We will need to cover up lots of kilometer, like 50 to 60 kilometers, so that your vehicle will remain on that 60 kilometer of track for 1 hour, right? In that 1 hour, your vehicle will get charged. Again, while you are charging your vehicle with wireless technology, there will be obviously some losses, right? So it's still in the development phase. Till now, we can't fully rely on that charging technology, but obviously in future we will make that better, and we will you will be able to see within the upcoming 10 to 15 years that there will be no not any kind of wired charging. There will be wireless charging. Just take an example of our mobile phones, right?
Yes, thank you,
Like
sir.
like before 10 years, we were connecting our mobile phone for that small chargers, 2-pin chargers. It was taking like 2 hours, 3 hours for getting charged. And nowadays, if you're you will try to charge your mobile phone with the fast charger, it will get charged within 10 to 15 minutes. Again, we are having wireless charging technologies. Again, we are having fast charging technology. So this is all of innovations. This is all of getting more advanced, right? As the time passes, the technologies will get more advanced. Yeah, any other questions?
Yes, sir.
Yes.
Sir, what is the electric vehicle battery management system, sir?
Battery management system is the brain of the battery, right? So it will get all the informations like what is SOC, means state of charge, what is the capacity of the battery, how much your vehicle can travel further, what is the temperature of battery. Again, it will contribute to increasing the battery's life. So all these things will be done by that battery management system. It's just like a computer, or it's just like a brain of the battery. Right?